We are continuing with chapter 1, all about solving equations today. Last week we did one-step equations, and we did a few multi-step equations where you had to combine like terms first, then undo the adding and subtracting, then undoing the multiplying and dividing. Today we're looking at those multi-step equations where it gets a little trickier. We're going to look at problems that start with variables on both sides. So our goal today is to get all the variable terms to one side first and then solve like normal. So do you see how we have x's on both sides of the equal sign? We need to get those together. We can't have like x plus 3 equals x plus 4. You know, like you can't, it's not solved, it's not isolated if they're in two different spots. So the first thing we need to do is get them together. We typically pick on the little guy. There are some instances where that's not going to work. But usually, just to keep things a little neater with our signs, we'll decide which x is smaller or which there are less of, and get those together. So if you have a 7x on one side and a 9x on the other side, it's easier to move the 7x. That's one reason to go with the 7x for this one. The other one, and this is when we sometimes won't pick on the little guy, if the x term is the only thing on that side of the equal sign, you don't want to move it because you'll end up with nothing and then everything on one side. That's not going to be helpful. We're going to end up kind of going in circles. So this one, for two reasons, it's definitely a good idea to start with the 7x. Since it's positive, we subtract it to move it to the other side. So now the 7x's on the left side are gone. I just have the 20 equals, and then you only subtract the x from where you already had an x. So even if there was something else like a plus 4 on that side, you would just leave that alone. You only, still got to do the like terms thing. So 9x minus 7x is 2x, and then we divide both sides by 2, and we get that x equals 10 or 10 equals x. What are your questions? All right, here's part B. Which one do you think we should go for? Good, and how would you move a negative or a minus 6t? You add 6t to both sides. Good. 4t plus 6t is 10t. The t's on the right are gone. The 50 drops down. Then what? Divide both sides by 10, and you get that t equals 5. Raise your hand if you have any questions. So for a few reasons, we'll add the 8/5 x. First of all, if you subtracted the 3/5 x, you'd end up with nothing equals a whole bunch of stuff. That's not how we solve equations that just have x's in them. The other one is that if you have a negative x term and you add it, then you end up with positive x's, and those are just easier to deal with. So either way, that's kind of our go-to on this one. Now, when you're adding fractions, even if they have x's in them, you need to make sure that you have common denominators. Do we have that? Yeah. We do, so that's wonderful. So 3/5 x plus 8/5 x is 11/5 x. That equals, we still have the 4 on the other side. Divide by 11/5 x is the same thing as doing what? Yeah, we're going to multiply by the reciprocal. So the 5's and the 11's are gone. You can think of that as a 4 over 1. So you multiply the 4 and the 5, the 1 and the 11, and you end up with 20 over 11. Do I change that to some sort of a mixed number?
No.
A decimal? No, leave it improper. All right, part D, lots more happening here. All right, what should I do to start this one? You need to distribute first, then you want to get your r's together. So I'm going to do 4 times r and 4 times the minus 9. 4 times r is 4r. 4 times the minus 9 is a minus 36. Plus 2. So there's a couple different ways you could do the next step. You could tackle your like terms, or you could get your r's together. It's really sort of interchangeable. I usually do all like terms first, then I get the r's together, but I've seen it done either way. So here, remember, this is a minus or a negative 36 plus 2. So we have 2 terms, different signs. So you subtract the numbers, keep the sign of the larger numbers. So we have minus 34. A lot of students would put minus 38 here. Remember, you got to consider this a negative. You're in the hole this far. You're coming back 2. Okay, so it's subtracting. Keep the sign of the larger one. All right, now you can get the r's together. So what should I do? You subtract 4r from both sides. I have negative 34 equals 12r minus 4r is 8r, and then just keep the plus 14. Now what? Subtract the 14. Now the signs are the same. They're both negative, so we add them, keep the negative sign. Negative 48, good. Divide by 8, and you get negative 6. Very good. All right, so after we distribute, we've got some like terms on the right. What is 2 minus 7? Negative 5. Good. I'll pause there, kind of let you catch up. Getting a little speedy on you. Okay. Then what? Subtract 2x. Now, I like when they work out like this, when it's like 3x minus 2x, because you get 1x, and 1x is the same thing as x. It saves you a dividing in the bottom, so, or in the last step, so. Perfect. Then what? Subtract 6 from both sides. X equals negative 11. What are your questions? What type of problem is this? A bodyguard problem. So who do I have to get through? 4. The 4. And we undo a big old dividing by 4 by doing what? Multiplying by 4. So I'm going to multiply both sides by 4. On the left, the only thing that happens is that these 2 cross out. Boom. And then on the right, you actually have to multiply the 5x and the 4. I've seen some people, like, they'll multiply the left by 4, they'll cross it out, and then they just sort of forget about it. Remember, this is a balance. Whatever you do on one side, you have to do on the other. Now I can add the 2x. Good. So I have 3 equals 22x. Divide by 22, and I just get 20 seconds. This is where you panic because your answer is wrong, right? A lot of students get really uncomfortable when they get an answer like this. It's fine, okay? I assure you it's going to happen. If you're nervous, plug it back in, okay? when you plug it back in up here, you have to plug it into 2 spots. And honestly, I'd just type it in my calculator. I wouldn't sit and do all this fraction work by hand. But it does work out, I assure you. Any questions? All right. We are going to find the number that is 32 less than 3 times the number. So once again, we got to start with that let statement. So I'm going to let n equal number. Find the number that is 32 less than 3 times the number. So I'm just going to show you, and then I'm going to explain it so you can sort of see where I'm going with it as I'm talking about it. Find the number that is. So number that is, that's where you get n equals. Remember, is sort of your breaking point in these word problems. That's where the equal sign goes. Typically, everything before the word is one side. Everything after the word is another. So you might even want to just like circle the is and focus on the 2 sides of the sentence around the is. So find the number is. So n is. 32 less than, that's where we flip the order of the subtraction. That goes at the very end. And then we're looking at 3 times the number, so 3n. Now, you might be saying like, how is the number happening twice? Well, these are the equations we were solving all day. So when you read it as the word problem, it kind of sounds like the number's coming up too many times. But once you actually write it out, it should look like those equations we've been solving all day. So again, write your let statement, find the word is, and then just sort of see if you can piece it together on both sides from there. How would I solve this equation? Subtract the 3n from both sides. Oh, sorry. I don't know why it's doing it this way. I disagree. I would get your n's all to the left side. This is one of those weird ones where usually we do pick on the little guy. But if I subtract the n, what would I have on the left? Nothing. I don't ever want to have nothing. So I'm going to go rogue. I'm going to ignore the PowerPoint for just a second. What is 1n minus 3n? Negative 2n. So a lot of times we want to avoid negatives, but sometimes they're just unavoidable. Now what? Divide both sides by negative 2. And look, you have a negative divided by a negative, so our answer is going to end up being positive 16. Now, a good way to check this one is just read through it again. 16 is 32 less than 3 times 16. So just do 3 times 16 minus 32 and see if you get 16. What? I just plugged it back in to the word problem. So what is 3 times 16?
18. Oh, no, I'm getting 6.
You're adding, I think. 48. Subtract 32. You get 16, so it does check out. But you got to actually do the math right. I know. Okay, for the sake of just a really good time, I'm going to show you how to do it the other way as well. So, you could subtract the n from both sides. Here's how you would write that. You would have just a 0 over there. Nothing in math is 0. So you could have the 0, then add the 32, then divide by 2, and you still end up with positive 16. It still works out, okay? So this is one of those things where maybe if, let's say you're working with a partner, you do it one way, the partner does it the other way, you could still end up with the same correct answer. Do what makes sense to you. Some people don't mind negative numbers. Some people can't stand negative numbers. Some people always pick on the little guy and they don't care if they end up with a 0 on one side. Just know there are multiple correct ways to do these problems. And if I ever do it a way that you don't like and you want me to do it your way, I can't. I can show it to you. Like, I don't mind doing a problem in two ways. A lot of students say, like, is this right? And I say, did you get the right answer? And they say yes, and then we move on. But if you actually want me to write it out, just let me know. All right. H. Keeping you on your toes. All right. I can already see what the biggest mistake on this problem would be. Does anyone else think they know what the biggest mistake would be?
Nope. Oh, nope. Is it that -5?
Yeah, a lot of students will just distribute a regular old 5 on the back end. You have to distribute the negative as well. So we have 3 times n, 3 times a -2, then a -1, then it equals, and then distribute that negative. So -5 times n is -5n. -5 times +5 is -25. A lot of students, I would see they just kind of drop the negative, so this term would be fine. It's this guy where they mess it up, so be careful. All right, I got like terms everywhere. So on the left side, what's -6 minus 1? Good. On the right, it's a +2, and then you kind of got to like jump to the back, -25. Very good. And you can put that in the front of the -5n. You could put it behind the -5n. It's up to you. All right. Now this is one I'm going to go off the beaten path again for a second because you could really make a good argument for either one. Do you have strong feelings here? Or do you have a question?
I have a question.
Yes.
Okay, so -6 and -1, right? I mean, yeah, that'd be -7, right? So wouldn't it be minus -7? So wouldn't it be -7?
Minus a -7 would be a +7. Right. Since they're both minus, we just have the one. Yeah. Once you combine them, it's just one negative. But good question. Okay. What I was saying is I could see a good argument for either one. I'm not sure what's pre-programmed up there, so I'm just gonna go off. I'm gonna take suggestions here. What do you guys think?
I had the 23.
So
Oh.
let's just vote. Do you want a -3n? Raise your hand. Do you want to add 5n? Raise your hand. Okay, we'll go add 5n.
Which one is it?
They're both right. That's the thing.
Which one they get?
I'm not sure what they have. Okay, now what? Add 7. Add 7. Yeah, so the signs are different. We're going to subtract the numbers to keep the sign of the larger one. So -16, which is great because that is divisible by 8. What do I end up with for n? -2. Everyone okay? Okay. All right.
Onward.
Whoa, quick summary. Today we learned how to solve equations. That's often a good strategy, but let's make our sentence make a little more sense. Today we learned how to solve equations with variables on both sides.
That was not wrong.
I will give you your homework. The homework's a little on the longer side today, but you do have almost a half hour, so you guys are going to be just fine.